Hi everyone. Alright, solving 3 by 3 systems. Alright, you'll probably be watching this during class because I don't think I'll get it loaded soon enough for you to do for homework. I'll just try to do better. But what we're going to do is solve 3 by 3 systems, and our goal is to get it into a 2 by 2 system. You use one equation in the system to eliminate one variable in the other two equations. Then solve the 2 by 2 system that is left, and then you go back and you get your third variable after that. And I have lots of good choices here. I could eliminate the x's and have y and z, or I can eliminate the y's and have x and z, or I could eliminate the z's and have x and y. I'm just going to start with the x's. So my goal is, and I'm going to use the second equation. It has just x. That makes it simpler. I'm going to use the second equation to eliminate x in this equation, and then I'm going to go through the process again and eliminate x in this equation. So I'm going to write the first equation, 2x plus 3y minus z equals 0. My second equation is x minus 2y minus 4z equals 14. Alright, to eliminate x, I'm going to multiply this one by negative 2, and when I do that, I have negative 2x. Now remember, and I saw every once in a while, you might not be remembering to multiply everything in the equation by the number out here. Plus 4y, because negative 2 times negative 2 is positive 4, plus 8z is equal to, even this number over here needs to be multiplied by negative 2, negative 28. And this is positive 2x plus 3y minus z equals 0. Now what do I get when I do that? I get the x's to cancel out. 3y plus 4y is 7y. Negative z plus 8z, negative 1z plus 8z is 7z. And 0 and negative 28 is negative 28. So 7y plus 7z equals negative 28. Let's just kind of save this guy for later here. It'll come into play in a little bit. Now, that was the first equation and second equation. I'm going to use the second equation again in combination with the third equation. So I'm using the second equation to eliminate x in this equation. X minus 2y minus 4z equals 14. 3x plus y minus 8z equals 17. I am going to multiply this equation by negative 3 so that I can get rid of the x in that equation. And when I do that, let me kind of draw a line here. I don't want to get this equation confused with what I'm doing down here, because this is separated from this for the time being. Negative 3x plus 6y, multiplying everything by negative 3, plus 12z equals negative 42. On this one, 3x plus 1y minus 8z equals 17. Okay, we eliminated the x's like we wanted. 6y and 1y is 7y. 12z and negative 8z is positive 4z. Negative 42 plus 17, I believe, is negative 25. Okay, now I've got this equation. I used the second equation in eliminated the x's from the first equation and eliminated the x's using the second and third equation. So at this point I'm going to take the two equations that have y and z in them, And I'm going to solve. I made a mess right here, but I'm not changing it. Let me write down here. 7y plus 7z equals negative 28. Right where you can see it. 7y plus 7z equals negative 28. 7y plus 4z equals negative 25. This is a 2 by 2 system like we were doing yesterday. I've got these 7y's here. I'm going to eliminate them just by subtraction. 7y minus 7y is 0. 7z minus 4z is 3z. Negative 28 minus negative 25. Be careful with that. Negative 28 minus negative 25 is negative 28 plus 25, and that's negative 3. I'm dividing by 3 here, dividing by 3 here. Z is equal to negative 1. So I have my z value of negative 1. Now the place to go, I think, is, that's one of the 3 variables. And I'm going to use one of these equations. Let's just use the first one. 7y plus 7 times negative 1 equals negative 28. I'm just using this first equation here. 7y plus negative 7 equals negative 28. I'm going to add 7 to get rid of that part of it. I got 7y equals negative 28 plus 7, which is negative 21. Divide by 7, and y is equal to negative 3. Well, there's 2 variables, 2 down, 1 to go. We need to get the x. It does not matter which one we use, but we have a value for z, we have a value for y. I'm going to use the second equation because it was so helpful. And in the second equation I have x minus 2 times y, which I'm using negative 3 in the place of y, minus 4 times z, which I'm using negative 1 now in the place of z, equals 14. Well, x, negative 2 times negative 3 is positive 6. Negative 4 times negative 1 is positive 4, equals 14. X plus 10 equals 14. Minus 10, minus 10. X equals 4. All right, I have an ordered triple now. X, y, and z. I hope you saw what I wrote for x earlier. X is 4. Y is negative 3. And z is negative 1. Now, do keep in mind what I did was I used one of the equations to eliminate one of the variables and get a new 2 by 2 system. Solve the 2 by 2 system, you get 2 of the variables, use those values and put in one of the original equations and get the third variable. That was what was done. If we check, 2 times 4 is 8, 3 times negative 3 is negative 9, 8 and negative 9 is negative 1, negative 1 minus negative 1 is negative 1 plus 1, which is 0. 4 minus 2 times negative 3 is 4 plus 6, which is 10, minus 4 times negative 1 is plus 4, 10 plus 4 is 14, 3 times 4 is 12, 12 plus negative 3 is 9, minus 8, negative 8, 8 times negative 1, 9 plus 8 is 17. I like that answer. What I'd like for you to do now is, I want you to work on this. Let's pause it. You solve it. And there's your chance to solve. I'm back. I'm wondering if that was your solution. If it was, fantastic. If you're getting this a second time, great job. All right, you'll be watching this, and I'll talk to you then.